Hello, this is Mrs. Sargent, and this is lesson 3.4, Noble Gas Notation and Electron Dot Structures. So, where are the noble gases located? The noble gases are located right over here in the purple in the far right column. Everything under helium, shaded in the purple, is a noble gas. A noble gas core is the electron configuration for a particular noble gas. So we have two noble gases, neon and krypton. To write out the electron configuration for neon, we always start at hydrogen, which is 1, energy level 1, the S sublevel. We go through hydrogen and helium, so 1s2. Then we go to the second energy level, the S sublevel, going through lithium and beryllium, so 2s2. And then we're still in the second energy level, the P sublevel, and we're going to go through all 6 of those columns, so 2p6. For krypton, we got to go all the way through neon to start with. So we're at neon, and then we go down to 3s2, and then 3p6, to 4s2. Then we got to go through the D block, which starts at energy level 3, 3d, 10, and then we go to the P sublevel, which goes back to energy level 4, 4p, and we need to go all the way through the P block, so 4p6. Notice that both of these they end in an energy level and then p6. So unless it's helium, it's always going to end this way. Some energy level and then p6, since it's in the far right column. So how do we write an electron configuration using noble gas notation? The first thing that you're going to do is you're going to locate the element that you want. And then you're going to trace backwards from that element to the closest noble gas. Write the symbol for the noble gas and put brackets around it. And then you're going to continue to write the electron configuration. So let's take a look at some examples of these. We want to write the noble gas notation for chlorine. So we're going to trace backwards. Our last noble gas is neon. So I'm going to put the symbol for neon in brackets. Then from neon, we're going to write our noble gas or our electron configuration like normal. So we're at 3s2. And then 3p, 1, 2, 3, 4, 5. Gets us to chlorine. So you might look at this and be like, oh my gosh, this is the shortcut for electron configuration. You would be correct. Remember I said that the electron configurations are like GPS turn-by-turn directions from your home to your friend's house? Well, think about the noble gases as like known locations, like work, school, your best friend's house, your grandma's house, something like that, these known locations, and you're going to then get your turn-by-turn directions from those places. So the next noble gas notation we want to do is antimony, which is Sb. So we're going to trace backwards to the last noble gas, which if you go up one row all the way over to the right would be krypton. Then from krypton, we're going to go down to the next row. So we're at the 5th energy level in the S sublevel, 1, 2. Then we're going to go into the D sublevel. So now we're at 4D, 10. And then back to the 5th energy level for the P sublevel. 1, 2, 3 gets us to antimony. For oxygen, why don't you pause the video and try to do oxygen on your own. Welcome back to write the noble gas notation for oxygen. Trace backwards. Our last noble gas is helium. Then we go down to the next row, which is 2s2. And then we're at 2p. And then 1, 2, 3, 4 gets us to oxygen. So that is how you write noble gas notation. So you need to now pay attention to see if it says the electron configuration, full electron configuration, or the electron configuration using noble gas notation. So for electron dot structures, valence electrons are the electrons in the outermost S and P orbitals. I shouldn't say orbitals here. Sorry about that. That are involved with chemical bonding. Elements in the same group or column share similar chemical and physical properties based off of the number of valence electrons. So everything in the 1A column has 1 valence electron. Everything in the 2A column has 2 valence electrons. 3A has 3, 4A has 4, 5A has 5, 6A has 6, 7A has 7. Helium is an exception, it only has 2, but everything else in this column, all the rest of the noble gases, have 8 valence electrons. So go ahead and write in the 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A numbers. That's going to tell us the number of valence electrons for the element in that group. So how do we draw electron dot structures? The first thing that you need to do is you need to write the symbol of the element. Then you are going to count the number of valence electrons and place the dots around the symbol one by one. Double up once each side has a dot. So just like with the orbital diagrams, they each got 1 helping of electrons, and then they can double. Same is going to be true for our electron dot structure. 1 dot on each side, and then you can go back and double up. So if you find lithium, it is in the 1A column. So it is going to have 1 valence electron. Phosphorus is in the 5A column. So we're going to put 5 dots around it. 1, 2, 3, 4, 5. And then for xenon, it has 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So it kind of makes this box around the element. So I'd like you to try these electron dot structures on your own. Go ahead and pause the video and then come back and check. Welcome back. So the first thing we need to do is we need to write the symbol for each of these elements. Bromine is Br, carbon is C, aluminum is Al, magnesium Mg, and sulfur is S. So now we need to determine the number of valence electrons. Well, bromine is in the 7A column, so it has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. For carbon, it is in the 4A column, so 4 valence electrons. So each side gets 1 dot. Aluminum has 3 valence electrons. So 1, 2, 3. This side doesn't have any because we don't have any to give it. For magnesium, it has 2 valence electrons. So 1, 2. And then sulfur has 6 valence electrons. So 1, 2, 3, 4, 5, 6. I recommend starting on the left side and then going clockwise. But wherever you start, just try to start there all the time so you don't confuse yourself as to where you stopped and where you need to start. So that is it for these notes. You have practice over noble gas configurations and electron dot structures. You do not need to do the electron dot structures for chromium or gold, but everything else you can do. If you have any questions about this, please stop by to see me, and I can help you with your questions. Thanks for stopping by. Have a great day.